everybody. Welcome to today's webinar, which is called Lowering the Barrier to Integrating Smart Press Technology. My name is Andy Joseph, and today I also have with me Glenn Nausley. And Glenn, do you want to do a quick introduction to Promess?
Yeah, basically this webinar, what we want to talk about today is talking about lowering the barrier to integrating smart press technology. Promess has, since the early 90s, we've been in business since 1984 selling sensing systems, but since the late 80s, early 90s, we've been one of the key suppliers to industry for fully electric presses with built-in monitoring. This is what we're going to be talking about today is not new technology. It's technology that we've really been offering the industry for 25 years or more. But a lot of what we've offered in the past has been for high volume and in the areas where we've done the integration in our systems, we've supplied our customers with a lot of control power and a lot of monitoring power. Well, what we're working on now as a company is taking this power and putting it into packages and bringing that technology to a level where it's much easier to integrate. So we want to talk a little bit about that today. That's really, the message we want to talk about. So one of the things that I wanted to start with is talk about the costs of the technology and where some of this integration costs are. And in my mind, I think about this integration costs with three levels. We have there's the integration costs, the operation costs, and the performance costs. The integration costs are, if you think about with a normal servo technology, you have to have a controls engineer, you have to be able to program it, you have the, so it's the initial setup, you have to understand the safety aspects and how to integrate in the different safety areas, and how are you going to control the press. With Promess technology, we offer the control and monitoring built into the same unit. Andy will talk a lot about this later. In normal press technology, you may have a servo press or a hydraulic press or a pneumatic press, and you will be controlling it with a PLC or some other control methodology. And if you want to do force and position monitoring or some kind of monitoring, you might add on a monitoring system. Integrating the motion control and the monitoring part of this technology or of this process, there's a lot of cost and engineering built into that. And so the Promess solution takes care of that cost for you. You also have to deal with safety. How do you deal with safety? How do you make sure that the process is safe and that the operator is not in any kind of danger as he's operating the press? Some of these presses can be quite powerful, so it's you can have some damage there to yourself. On the integration side, Andy, can you think of, have I missed anything in integration?
Well, you mentioned safety, and if you have an existing press, oftentimes what we see is that there really isn't any safety at all. And so you're basically starting from scratch, and you have to either decide, do you want to put a barrier around it, or do you want the operator to actually have some interaction with the press? And that's where a lot of the integration cost comes in on the safety side, is coming up with that ability for the operator to actually get in there and put parts in and out and that sort of thing. So
okay. Yeah, so the integration at the very beginning of the project, the integration cost is one area. The other area of cost is operational cost. What does it cost you to maintain the product? You have energy costs. You also have changeover cost, job setting. If I'm running part A and I need to change over to part B, how long does it take me? Is that something I can do very quickly? And not even talking about changing over parts from part A to part B on the fly, but I have a new part. Let's say I've been running part A and part B for years, and now somebody, my manufacturing, I need to add in part C, a different variant. How long does it take me to change my process where I can run a third or fourth part type? And one of the things that Andy will be talking about is how quickly we can make those changes. So the operational cost, how quickly, how much cost is it in maintenance, energy, any types of environmental things, or changing from one part to another. Any additional things you can think of, Andy, on the operational costs?
No, I think that pretty much covers it.
Okay, and then lastly, the third layer of cost is in performance. And this is the most important, really.
The most expensive.
The most expensive, yes. I mean, this is where really where you can save a lot of money with the right technology. We're not making money, you're not making money if you're not shipping good parts. And so the most important thing is making higher quality parts on time, having up the machine uptime, and if you do make a bad part, not shipping that bad part out. Not that, the first thing is don't make bad parts. The second thing is if you do make a bad part, don't ship it to your customer. Make sure you catch it in-house. You catch it at the station. And you also don't make 10 or 20 or 100 or 1,000 bad parts. You catch the first bad part. And if you find you catch the first, the second, the third, the machine will alert you to say, hey, there's something wrong. We need to fix this problem before you make a series of bad parts. So with Promess technology, we believe we can save you money, save you cost in all three of these areas.
Well, and let's not forget too that a lot of times your customers may be demanding proof that you're making good parts. And so there's also the, you need the ability to provide that proof to them in terms of data or some kind of factual information. I think that's a good coverage of the integration costs and operating performance costs.
Yeah. So yeah. What we will be talking about the rest of this webinar is whether how we can save you these costs and what some of our new developments are. A lot of these costs, Promess's standard press technology that we offer for years address this, but we have some new developments that lower the barrier to integration of this technology so that more people can benefit from this technology.
Yeah, absolutely. So what I want to talk about briefly is what is a smart device, smart press. And I came up with a definition a while back that kind of guided some of our development efforts. And so essentially a smart device is a context-aware electronic device capable of performing autonomous computing, as well as connecting to other devices by wirelessly for exchanging data. And I felt that was that kind of captured a lot of things we were trying to do with this kind of technology. So many of us have smart devices, right? I mean, we have smartphones, we have smartwatches, Nest thermostats. I have a whole bunch of stuff at home that I really enjoy. They're all smart devices. And what I want to do is try and kind of relate this to press technology. So first of all, let's talk about context awareness. So a big part of that is sensing, right? Because all these smart devices have a variety of sensors in them. You think about your smartphone. I mean, I think nowadays the average phone has 4 cameras on it. And I even came across a phone that was developed that had 16 cameras in it. Crazy to think about, but that produces a lot of data, right? And they also have accelerometers in them. They have microphones, GPS systems. It's just amazing how many sensors you'll find in today's smart devices. But when it comes to presses, what that really means for presses is the biggest thing is force sensing. That's something that a smart press should have that built into it. It should have it integrated into it at a level that that can be used for controlling it and also protecting the press. And then there's also position feedback. A smart press by its nature is going to be electromechanical in nature. It's going to have that precision, that very precise motion control. And so position feedback is extra data that's coming from that. There's also other pieces of what I call operational cues that come into play. And so, for example, if you're running in a high mix environment, you're going to be dealing with multiple part models. So knowing what part model it is that the press is actually working on is a piece of contextual information that can be used in that smart environment. Then also things like serial number, even what the safety controls are doing, like how often is the operator breaking the light curtain. Cues like that can actually be very useful in a smart context.
Just to add to that, when you're talking about like smart, I know a lot of people, you think about artificial intelligence and smart devices and things, and you're thinking about the computing power. But if you think about even the human being, we have five senses. If we're not sensing our environment, all the computing power we have in our brain is not very valuable. You can have a really smart device, intelligent devices, and without the sensing, is it really smart if it can't sense its environment, if it doesn't know what's going on in the process, if it can't use external information to make decisions? So it's something I think a lot of people miss when they talk about smart devices. Is you're talking about the cameras and things, being able to, for the machine to be able to sense its environment, being able to sense what's going on in the process, being able to feel what's going on and make decisions on the fly.
Yeah, I mean, sensing is key to smarts, right? That's how things reason about the environment and are able to do autonomous things. So speaking about autonomy, uh, the thing where smart presses can really help is that they should really know your application. Um, Compare that to some of the more manual presses out there that have a lever on it, right? They don't know your application, and really it's up to the operator to know that and to be able to operate that press in a way that will do that application. With a smart press, there should be smarts in there that says, okay, I know that you're going to press a bushing in. I know that you're going to press in whatever that part is. And really, the only thing you need to decide to figure out is how much force will that take, and what are the quality criteria to make that to actually make that correctly. And so take your Nest thermostat for example. It knows what a heating system is. It knows how heating systems respond to, especially in relation to human comfort. And so the basic thing you do with a Nest thermostat is you install it and you let it learn its way to whatever that human comfort level, should be satisfied. And same thing with the smart press is that once it knows essentially what kind of part you're trying to make or the type of process you're trying to do, then it should be a fairly easy thing to adapt to new kinds of similar parts and to be able to configure them quickly and to be able to produce those parts with quality. So
Your analogy with the arbor press is, I think it's a perfect analogy. It's, if you think about that, the smarts with an arbor press is the human brain. The sensor is the guy's shoulder, the arm,
yep.
the muscle. You can feel what's going on. And what we don't recognize is when you're doing something with an arbor press or something, you're making decisions on the fly. So you think about with a fully electric press with the sensing and the smart technology built into it, it's basically emulating the human touch, but improving it because we know computers can act so much faster, so much more precise. The servo technology, it can move in microns, it can measure much more accurately. So it's it's replacing the human feel and the human control, but it's amplifying the capability because it's so much faster and so much more powerful in its calculation capabilities.
Yeah, that's really what's happening there. So again, there's context awareness. We talked about that. There's the autonomous side of what a smart device is, and lastly, there's the connectivity aspect. And 20 years ago, these types of devices and stuff were not very good at connecting because we didn't have wireless standards, and we're still using very basic Ethernet technology. But now it's advanced to the point to where connectivity is almost a given, with practically any device that you get. So, as it relates to presses, Ethernet is definitely the common denominator, and we're starting to see some wireless connectivity, but it's still not quite widely accepted for performance and security reasons. We also see that OPC UA is becoming starting to gain some acceptance, especially as it relates to getting data, from the device. But there's other standards like MT Connect. I know MQTT is also becoming popular in various contexts. But by and large, I would say the biggest connectivity option that we see is field bus. So if you have a PLC, if you have some kind of a SCADA system, a smart press should be able to allow you to tap into that through some kind of field bus technology. Yeah, so context awareness, autonomy, and connectivity. Those are the three things that I think really define a smart press.
Yeah, and with the smart press, the press itself has a level of smartness, of course.
Yep.
It has the sensing, it has the control. And for a lot of our applications, that's it. That's enough information to improve the process, make better parts, and monitor that every part coming out of the machine is a good part.
Well, and to adapt to new part models too.
Yeah, exactly. And the connectivity just adds, because if you are connected to external devices and you're getting additional information from those external devices, that's even more information that the smart press can react to and can make decisions with. So yeah, there's these different levels of smart technology, and a lot of it is, the levels are based off of part of it is how intelligent the device is, but part of it is what information is it getting and what information does it need to make proper decisions.
Yep, certainly. Glenn, do you want to talk about some of the industry trends we're seeing?
Yeah, one of the things that everybody's kind of struggling with right now, I know, is there's a skills gap question going on, and a shortage of skilled workers, and on with that's one of the things that we're working on with this smart press technology, and trying to lower the integration costs and lower the integration complexity. A lot of it, when we talk about cost, complexity adds cost. So if you're lowering complexity,
Sure
you're
does.
lowering cost. And our goal is that you should be able to implement a smart press, possibly in less than an hour, to have it, out of the box on to the shop floor, making parts in less than an hour. The uh, the technology, there's a lot of power in the servo press technology with the smart press technology, but if you have to have a very high level controls engineer who has to be involved in setting this up, it can definitely, you're limited sometimes in some industries to whether they have the technical infrastructure in their plant to be able to handle this level of technology. Well, what we're working on with these smart devices is lowering that complexity for the initial installation of the press, the maintenance of the press, and the use of the press. And what we're finding is it's opening up the capability for other manufacturers to be able to use this technology. Promess has grown up. We did a lot of our growth in the automotive industry, and industries that tend to have controls departments, high levels of technical support, and IT departments. Well, this specialization of smart presses, that's really where it was born, and a lot of the growth of the technology and the capability was developed in this area. But what we're working on now with these smart presses is to be able to take that same capability but put it in a form factor where you don't have to have that high level of infrastructure, the technical infrastructure, to be able to implement it. So what we found is that it really opens up the technology to other industries, and a good technician can implement this. You don't need to have a PhD type of controls engineer to do it. So that is one of the trends which we're seeing, and then the other trends are as far as being able to companies are in a lot of the old plants, you might make 6,000 of the same widget a day, and it's the machine is just continually making the same widget. We're seeing more and more operations where it's more batch and more lot, and there's a lot more changeover, and so it's more high mix, low volume type of applications. And again, this technology really suits that very well, because the changeover can be done so quick, and normally it's just a change of a program.
Yeah, and oftentimes the tooling too. So So you talked about some trends. What I wanted to do is tie this back to something that Promess actually offers today, which we call the FlexIQ. The FlexIQ is everything that we think of in terms of a smart press, and we think that it really does lower the barrier when we're talking about some of these costs. So first of all, the FlexIQ has built-in force and position sensing that comes baked into it basically, and so there's really no need for that additional cost of trying to find the right sensors and the right monitoring system, or trying to even control that, be able to control the force using using other technologies. Also, the FlexIQ, because it is a smart press, again, it knows about your part, it knows about the process. And so there's very little thought that has to go into, okay, do I need to use this algorithm or that algorithm? Do I need to actually do some programming to get this to do what I want to do? All of that's been taken care of, in the FlexIQ. And really, it's just a matter of doing a few easy steps to configure it for a new part. And in fact, we have this thing in the software, the FlexIQ, we call it a part model wizard. And so when you literally take it out of the box and you power it on, assuming you have your tooling all set, you can go through a simple 5-step process, and it literally looks like a wizard. You're just walking through these 5 different steps, and within a matter of minutes, you could have it set up and running that part. Because all of the decisions that relate to some of those basic settings are taken care of, by the smarts of the press. Also, I'll add that it's easy to move around. We actually designed this the smart press to be fairly lightweight, and it's also self-contained. So all the controls, all the software are actually built into the press. So the only thing you have to connect is power. A data connection if you're trying to, obviously you need to set it up with a computer, but then and then if you do your own fixture, if you do your own integrating a start switch, things like that, then there might be a couple of digital signals you need to apply, but that's it. I mean, everything is contained in the press, and it's pretty mobile from that standpoint. And also, you don't need to have an electrician on staff to be able to hook it up, because it runs off of 24 volts.
Yeah,
It's a safe voltage.
Yeah, you plug it in, you power it with 24 volts, and the programming, as you said, it's a very simple process. And you define what you are you pressing a bushing, are you pressing a bearing, are you crimping something? You define the process and how you want to monitor it. And it's basically set up and ready to run. It's very simple to set up.
Yeah. And our sales and our apps team are available anytime if you'd like to see a demo of that. We have online demos and in-person demos. So
one of the trends that I missed, that I thought about as you were talking, is also the data acquisition.
Yeah.
More and more customers are wanting to collect data and be able to, a lot of times maybe their customer is demanding that they supply documentation showing that the parts were actually made properly and so on. So that is all kind of standard with these products.
And we're also seeing folks out there who also want to use that data to try and do some data analytics or some modeling of processes and stuff like that. So we're definitely seeing a lot more of that interest.
What I found is it's really interesting that a lot of times customers that haven't used this technology in the past, they get excited by the technology because of the programmability and because of the ability to monitor in real time and be able to say whether they're making a good or bad part, and is the good or bad, are they shipping good or bad parts. They recognize down the road the value of the data. They didn't even, I mean, I've had multiple customers who 3 months, 6 months, a year later recognize how much they've learned about their process because now they have this data they never had before. So there's long-term value, there's the short-term value, good or bad now, and then long-term value in the data to understand your processes better.
Yeah, for sure. And when I mentioned earlier about the contextual cues, those things can actually be used later on to be able to trace back issues in the process, issues in your supply chain, to be able to actually tie it back to some real causes. So again, data collection, has a lot of value, especially, trying to error-proof your operations. And last thing I'll mention about the FlexIQ is that it's essentially future-proof. It has an optional field bus if you want to be able to collect data or to be able to tie it to a PLC. It's also a lot of the connectivity aspects are based on web standards. All of that's easily used by other systems, or data can be consumed by other systems. And also, we're going to be adding a lot more intelligence in there in terms of knowing more kinds of parts that are out there, and being able to anticipate some of the things that it's going to be able to do.
There's
so
a growing smart library.
Yep. So I think that concludes everything that we wanted to talk about today.
I think we have some questions.
Yep. Let's get some questions going.
So the first question, how is the FlexIQ software configured?
Yeah, good question. So like I said, all the software is basically contained in the press. And again, it's based on latest web standards, and so it actually serves up a software interface using a web-based app. And all you need is an ordinary notebook PC or something like that to be able to bring it up on the screen and go through the wizard, configure it for a new part, and also to set it up for if you want to use a PLC, for example, you can set that up in that web-based software.
So I have to have a PLC?
You don't have to. No, in fact, many customers are fine just having just a cycle, two-handed cycle start or something like that to initiate a cycle, and that's all they need. Typically, you don't really need a PLC unless you want to start collecting data, or maybe you might have a high automation environment.
Maybe coordinating
with something else. Yep.
Yeah, so the PLC is not needed for the press at all. It's really to coordinate part in, part out, or cycle starts and things like that. The actual control of the press and any kind of data and stuff doesn't use a PLC.
Yeah. In fact, we had one customer that just wanted the field bus interface so they could take some data and put it into their MES system. So we see some of that too. So
second question that's up here is, what kind of machine safety options are there? And you mentioned the two-handed anti-tie down.
There's that. Yeah.
Light curtains.
And the most simplest thing is just to put a barrier around it, but that can be a little restrictive.
A lot of these processes are manually loaded, so generally those are light curtain or two-handed anti-tie down. You can also have a door, and all that's possible.
And there's certain safety devices too that are coming out. I know LiDAR is coming around now too, to where you can actually use camera technology to implement safety, but that's fairly new stuff. I haven't seen a lot of that out there. But basically, you want to get with your supplier of safety equipment and see what they have to offer. The press itself, basically, we have dual STO inputs, so that covers the safety aspect on the press, and then so it's.
Yeah, and Promess has a team of application engineers that can, Promess can supply the safety. In fact, in a lot of the systems, we supply the safety, or our application engineers can work with you on your solution.
Any more questions?
I think that was it on questions. So anything you want to add? Any closing thoughts?
No, I just want to encourage everybody to book a demo, reach out to us if you have any questions.
You can reach us at our phone is 810-229-9334, or our website is promessinc.com. And so definitely reach out to us. And we have our next webinar is December 15th, 2021. And so that's not next year, but
that's going to be a fun one though, right?
Didn't really. This is a Just Smash It webinar. We figured it's around Christmas, so we're gonna try and have a little bit of fun and just really just smash some parts for you guys.
I think we need to smash some pumpkins.
Yeah, that's actually
Thanksgiving's going to be over soon.
Yeah. So Catherine Lytle, our producer, would have yelled at me if I didn't advertise the next webinar. So So anyway,
Yeah.
thank you guys very much. We appreciate our audience, and please, if we can answer any press questions for you, or if you have a pressing need, we're here to help you out. Thank you
Thanks,
very much.
everybody. Thank you.